So the sub handed out the Geometry Unit 3 calendar. I want to point out a few things to you. We're going to go through section 1 and 2 today and tomorrow, and then we're going to do an activity Thursday and Friday, and then another section on Friday. Monday we're going to have our quiz, our first quiz, and then 3 and 4 the following Tuesday, Wednesday. Going to practice some more, have another quiz the following Friday. Then Monday we're going to do another section, and then we're going to work on some proofs on Tuesday and Wednesday. Thursday we'll review, and then Friday the 27th we'll have our Unit 3 test. Today we're going to go over congruence and transformations. This is section 1 of the Unit 3. We're going to talk through this lesson today. So our objectives are to draw, identify, and describe transformations in the coordinate plane, and by the end of today, you're going to know how to use the properties of rigid motions to determine whether figures are congruent and to prove that those figures are congruent. So our vocab. First word is a dilation. It's a transformation that changes the size of a figure but not the shape, and this is when we stretch or shrink a figure to create a similar figure. The other word that we have on here is a rigid transformation. It's a transformation that does not change the size or shape of a figure, and we called this an isometry last unit. So let's talk about what kinds of different transformations are there. Remember again that a transformation it's a change in the position, the shape, or the size of a figure. So some types of transformations are translations. We called those slides. Reflections, we call those flips, and rotations, which are turns. Now the one we didn't talk about last unit was dilations, and that's when we enlarge or shrink a shape. So on your notes now, go ahead and go to your notes, and we're right at the top of the page where that first blank is. A dilation with a scale factor where k is less than 0 and the center goes from the origin, it maps xy to kx, ky. Well, k is what we call the scale factor. So when the scale factor is greater than 1, it creates an enlargement. So that means k is any number bigger than 1. That could be 1.1, that could be 10, that could be 100, but any number bigger than 1. So in that blank, go ahead and write enlargement. And to the right of there, you might want to write bigger than 1 because that's what that k is greater than 1 means. The next blank, the third blank up there at the top of the page, says when the scale factor is between 0 and 1, it is a shrink. So basically this means that k is now a fraction or a decimal. And when k is a fraction or a decimal, we know that the shape is going to get smaller. So this image over here is just, this is our origin, this is our xy, and it's just going to get bigger whenever we multiply it by a scale factor that's greater than 1. Now, if k was a fraction or decimal, it would actually go down here and get smaller. So now we're going to talk about representing transformations in the coordinate plane. So we've been over all of these except for a dilation, so this should be a review for all of y'all. When we translate xy by a units horizontally and b units vertically, that is the transformation x plus a, y plus b. Next, we're going to talk about reflections. When we talk about reflection, when we reflect across the y-axis, that's going to be the reflection negative xy. Remember, I said when we reflect across the y, we change the x's sign. When we reflect across the x, we change the y sign. These are our two rules, and again, this should be review for y'all because we just had a test on this on Friday. Then we're going to talk about rotations. Now, the way this is represented here is a little bit different, so let's talk this through. It says a rotation about 0, 0, which is the origin, 90 degrees clockwise. We're used to counterclockwise. Well, you should know that if it says clockwise here, 90 degrees, then it's 270 degrees counterclockwise. So that is going to be y negative x. When we talk about a rotation about the origin, again, 90 degrees counterclockwise, counterclockwise is going to be our normal rotation. So that's going to be negative yx. And then a rotation about the origin 180 degrees is negative x, negative y. And again, you guys should know all these rules. We just went over them last week. So dilation. Now this is the one that we're going to cover today that's new. When we're talking about dilations, we're going to multiply all of our numbers in a dilation by whatever our scale factor is, and that's going to be k. So in this case, we're talking about kx, comma, ky. Now, k can never be negative, so it's got to be a positive number. So that's what we're talking about as far as dilations are concerned. Transformations and congruence. So translations, reflections, or rotations, those all produce congruent preimages or images from their preimages. Dilations that have a scale factor anything other than 1 produce an image that's not congruent to their preimage. So a dilation that's between 0 and 1 would shrink, and a dilation that was greater than 1 would enlarge. Now it wouldn't be 1. A dilation of 1 would just give us the same exact image again. Remember, in a transformation, the original figure is the preimage and the resulting figure is an image. Hopefully y'all got that right on the test on Friday. Okay, let's talk about example 1. So we're going to draw and identify transformations. We're going to apply the transformation M to the polygon with the given vertices and identify and describe the transformation. So this says that we're going to transform xy by subtracting 4 from x and adding 1 to y. Hopefully all of y'all know that when we do that, what we're going to get is a translation, 4 units left and 1 unit up. Again, we just did this on Friday, so this should be very familiar to you guys. So when we look at our original image here and we translate it, so we look at PQR and we translate it, and if you guys recall, hopefully you guys recall that I said another way to tell this is to go ahead and map our vertices to each other. So if I map that one to there and that one to there and this one to here, you should be able to see that all of those are parallel and that they are all the same length. And if that's true, then we can say that this is a translation. Now, the way we could find that if we didn't even have the rule on the paper is we could count it. So we look at our original image here and we went 1 to the left, 2, 3, 4. So that's 4 to the left and then 1 up. So that's our transformation. It was 4 to the left and 1 up. All right, now let's look at this next example. Again, they give us the transformation. This is x negative y. And if you didn't know what that was, then you should be able to look at the image again in this drawing and figure it out. So now we have ABC and ABC prime. So again, I'm going to draw my lines from my vertices. Now something I immediately notice is that they're not the same length. But I do notice that this right here is bisecting those lines that I just drew from A to A prime. And it's a right angle to all these. So I could use what we learned last unit as well to determine that this is a reflection over the x-axis. All right, down at the bottom, we're on letter C now. This one again gives us the transformation rule. And again, if we didn't know this, then we could look at the drawing and we should be able to see that if we have EC over here, EC goes from horizontal to vertical. Hopefully you noticed that. So that's an indication to us that it's rotating. Now remember, rotations go this direction. So we could say that it rotated 90 degrees clockwise, or we could say 270 degrees counterclockwise. Either way, you should be able to recognize what happened in that drawing by the rule, because we memorized those rules, hopefully. So it's a 270 degrees rotation with a center of rotation of, again, the origin. D. This one now says xy becomes 3x, 3y. And if you look at the image again, you should be able to tell. We can take one of these sides. So this side right here, ln, is 1, whereas this ln over here is 3. So we could have figured out what the dilation factor was, and hopefully all of y'all can see that it did get 3 times bigger. So this time what we're looking at is that the dilation with a scale factor of 3, and again, it has a center at the origin. So a preimage is transformed with one of the rules below. Describe the transformation as a dilation, reflection, or rotation. Now we're on the back of the paper. Go ahead and flip it over. What I want you guys to do here is I want you to tell me, was it a translation, a reflection, a rotation, or a dilation? And I want you to tell me by how much. So how much did it move left, right, up, down? Did it reflect over the x-axis, the y-axis, the line y equals x? Did it dilate, and by what scale factor? Did it enlarge? Did it shrink? And then did it rotate 90, 180, or 270? Go ahead and do that. Go ahead and pause the video here. And when you guys are done, he can start the video back up and you guys can check your answers. Okay, so now number 1 says xy is transformed by x plus 2, y minus 2. So we should all know that this is a translation and it's going 2 right and 2 down. Number 2, xy transforms to be negative xy. So hopefully you guys know if we change the sign of x, it's a reflection over the y-axis. Number 3, xy becomes 2x 2y. So this would be a dilation, which would be an enlargement by a scale factor of 2. And number 4, xy becomes negative yx. This one is going to be a rotation, and it's going to be a 90-degree rotation. Hopefully you guys remember all this stuff. Okay, so now we're going to go on to example 2, and we're going to determine whether the figures are congruent. So we have shape ABC, and we have, which is a triangle, and we have triangle PQR. Well, they look pretty similar to me, but we're going to go ahead and check this out and see if we can tell. So again, I'm going to draw some lines for my vertices here. Those lines, again, all look parallel to me, and they look like they are congruent. This, again, should tell me that this is a translation. So let's now figure out what the translation is. And I'm going to show you 2 ways to do this. So one of the ways to do it is just to count. So if we look at our original image, A, B, C, how far did PQR move from ABC? So I noticed that it moved 1 to the left. And then how far down did it move? So let's take the same point A and go down to where P is. So it goes 1, 2, 3 down. So it moved 1 to the left and 3 down. So if we're going from ABC to PQR, it went 1 to the left and 3 down. And that would be true of any one of the points that we would have chosen. Now there's another way to do this. And so I'm going to put an equal sign underneath here. We're going to look at this. So we're going to look at A and P and we're going to compare them. So A is negative 3 and P is negative 4. And so what do we have to do to negative 3 to get to negative 4? We would subtract 1. And then what would we have to do to get from 1 to negative 2? And we would have to subtract 3. So that's a vector. And we could do this with any one of those points and see that it's true for any one of them. So let me do it here. So again, what would I have to do to 2 to get to 1? We would subtract 1. What would I have to do to 3 to get to 0? We'd have to subtract 3. Going to go ahead and do it with the next one as well, just so you can see it one more time. What do I have to do to get to 0? Subtract 1. What do I have to do to get to negative 2? Subtract 3. So notice here now we have a vector. And what does that vector communicate to us? Exactly what we saw in the graph, which was that this is a translation where we move 1 to the left and 3 down. And we could write that as a rule by writing that x, it becomes x minus 1, y minus 3. Now, again, remember, all of the things we've learned, a translation, a reflection, a rotation, they always keep the images congruent. The only one that changes the size of the image is a dilation. This is a translation. So now let's look at B. This one says, again, it gives us A, B, C, and then it gives us PQR. Well, here again, I'm looking at this image and looks pretty much like a dilation to me. So let's compare some sides here. So we've got 2 here and 1, 2, 3 there. We've got 2 here and 1, 2, 3 there. So looks to me like it's going to be a dilation. with a scale factor of 3 over 2, but I'm going to talk to y'all about how we got that. Okay, so all eyes up here. So when we do scale, when we're trying to find a scale factor, what we want to do is we always take an ending point over the beginning point. Now I'm going to demonstrate that to you. So up here we got A and P. So with A we have 2, -2, and with P we have 3, -3. So what we're going to do is we're going to take this ending point P, we're going to take 3 over 2. I think that's my scale factor, and we're just going to start comparing this with all our points. So notice that -3 over -2, two negatives over each other, turn it into a positive, so that's still 3 over 2. So that's our scale factor for those 2 points. Let's go on and check the next ones. So when we deal with B and Q, this was 4, -2. This one was 6, -3. Again, so when we do the ending over the beginning, 6 over 4, that reduces to be 3 over 2. And then again, we've got -3 over -2. And again, because we have 2 negatives, we know that that makes a positive. So this is still 3 over 2 and 3 over 2. Our final one is C, which was 4, -4. And then we have R, which was 6, -6. Well, I know because I just did it that 6 over 4 is 3 over 2. And again, -6 over -4 is still 3 over 2. Let me put a comma. 3 over 2. So you should be able to see here that the scale factor for every one of these was 3 over 2. Now, if you don't know, 3 over 2, 3 divided by 2 is 1.5. So our scale factor is 1.5. So you can pause the video here for a moment if they want to go ahead and write all this down. And then click when you guys want to start back. Okay, so now I want to talk to y'all about how you would write this out, what actually occurred here. So when we go to write our answer, we're going to say the triangles are not congruent. Why? Because one is bigger than the other one. Triangle ABC can be mapped to triangle PQR by a dilation with a scale factor of K does not equal 1, it equals 1.5. So XY transforms to be 1.5x and 1.5y. So again, you might want to pause the video here so they can write this down. Okay, so now we're going to go on to the next one. So I need you guys to do this, check it out, 2A. You should plot DEF first. And then when you're done with that, you should go ahead and apply the transformation 3x, 3y to the polygon with the vertices of DEF. Write your coordinate points and then tell me what happened. So go ahead and pause the video while they do this, and when they're done, you can go ahead and bring it back up and check. Okay, so now what we're going to do is we're going to multiply 3 times 1, which is 3. 3 times 3, which is 9, so our new D prime is 3, 9. We're going to multiply 3 times 1, which is 3. 3 times -2, which is -6, that's our E prime. And 3 times 3, which is 9. 3 times 0, which is 0. Then we're going to plot those points DEF. And you should immediately see that this triangle that we just plotted, DEF prime, is 3 times as big. And we can find that out by counting 1, 2, 3, 4, 5 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And if we've got 5 here and 3 times 5 is 15, we absolutely proved that this is a dilation, an enlargement by a scale factor of 3. So here again, you might want to pause it so they can check their answers and write down what occurred here. Okay, so I want you guys to go ahead and do the check it out example 2B. You're going to again determine whether the polygons with the given vertices are congruent. Support your answer by describing the transformation. So go ahead and plot A, B, C. And then I want you to plot PQR and see if you can tell by looking at the drawings what might have happened with these, and make a prediction, and then we'll see what you get, what you guys think. So go ahead and pause the video while they do that, and then turn me back on in just a second. Okay, so now I plotted ABC over here, and I went ahead and plotted PQR. When I plotted PQR and ABC, when I look at these, they look to me, because I look at AC and I look at PR, and AC was vertical and PR is horizontal. So I'm thinking this is a rotation. So the way to figure that out, again, guys, is we can look at these points, right? A and P. So look here. What do you guys notice already? 2, 1, 1, 2. So we can see that that's YX, right? Now, which one changed signs? It was the negative Y. That rule would be true for all of them if you went through and checked them. So again, a great way to do this is to go ahead and check that rule with all of them and make sure that it is true. Well, it is. So the triangles would be congruent because it's a rotation, and it's a rotation 90 degrees about the origin. So here again, remember, rotations, reflections, and translations produce congruent triangles or shapes, whereas a dilation, the shapes are not congruent. And that's really our objective here, is to determine when are shapes congruent and when are they not. And they are always congruent when we do those 3 transformations: translation, reflection, rotation. But when we do a dilation, the shapes are no longer congruent. Okay, so now go ahead and hand out the homework. Pause me for a second and then start me back up once you've handed it out. So I want to bring you guys' attention to what I'm expecting in this homework. So I want you guys to go ahead and apply the transformation that's up there for number 1 through 4. And then what you're going to do is you're going to give me the new vertices. And then I want you to tell me what happened. Was it a translation, a reflection, a rotation, or dilation? And then tell me how much under the description. That's what I'm looking for. Like, did it move left to right, and by how much? Did it rotate 90 degrees? Whatever. So, and then down, when you talk about 5 through 10, or actually, let's talk about 5 through 8. So 5 through 8, here again, I want you to figure out now what happened just by giving the points. And I want you to kind of see, what do you see? Can you see a rule that comes out when you're looking at these? And again, remember, the shapes are congruent if it's a translation, a reflection, or a rotation. But if it's a dilation, the shapes are not going to be congruent. So again, I want you to tell me the type of transformation under there. Tell me, again, translation, reflection, rotation, dilation, and by how much. And then for 9 and 10, go ahead and tell me again whether the shapes are congruent or not, and what type of transformation occurred.